So matrices are going to help us organize data, and we're going to see in the following examples why we set up matrices and why matrix multiplication works the way that it does. Now, if you read this question and you had to figure it out, you could figure it out. It's not hard to do, but it's going to see how the matrix operations can help us. So we got balls, bats, and gloves for 4 different stores. Balls cost $8 each, bats cost $30 each, and gloves cost $75 each. So we want to write the total order as a matrix A. Okay? See, am I missing? Let's go here. Oh, this is the, yeah, so there's the different stores and how many they want to order of each. So when you're making this as a matrix, one thing, we're just going to put these numbers in a box, 70, 60, 70, 50. It's going to be matrix A. 30, 20, 15, 40, and 22, 19, 24, and 12. Balls, bats, gloves, probably not good to use the same letter, so I'm going to call this one BA for balls and this one BA for bats. Oh, that doesn't really help. Babat. There we go. And then PQRS. PQRS. So we can add some labels just to help us remember what things were as a total order. What size of matrix is this one? A 4 by 3. Write the cost per item as a column matrix B. Now the reason I'm going to do this one as a column matrix B, we'll put the cost there, and then balls, bats, gloves. I'm just going to write bat here. Keep this one. Balls are 8, bats are 30, and gloves are 75. And this is a 3 by 1. So this is the first time that we've actually been asked to do some math here. We want to create the total cost per store. Now, if you didn't have matrices, you could figure this out, right? You look at the stores here. Store P, 70 balls. What are you going to have to do to that? You're going to have to multiply that by 8. And then store P's 30 bats, that gets multiplied by 30. And 22 gloves times 75. And their total cost, you would take each of those things and add them up. Can you see how that's very similar to what we were doing with matrix multiplication? Each individual thing in this row corresponds to the cost in this column, and then to get a total cost, right, you're going to put those together and add them up. Now, when we look at our matrices, and I'm going to cheat a little bit. I'm going to copy this one out again. Whoa. I'm going to try to cheat. Whoa. I'm going to start selecting from over there. There we go. Edit, copy, and then paste it. There we go. Oh, no. Okay. Here we go again. There we go. Whoa. Happy. That was not very efficient. I am not going to try to do that with the other one. The other one I'm just going to write down. Our cost matrix, which was right here, our cost matrix was, remember the numbers, 8, 30, and 75. Yeah, that looks like a big 8. There we go. So 830 and 75. Now something that matches up, we can multiply these together because it's a 4 by 3 times a 3 by 1. The middle numbers are the same. So that is allowed. What's cool about matrix multiplication, and one thing you have to be careful about matrix multiplication, is that not only do the middle numbers have to match up, but they have to match up with what they stand for, right? Because this was babatka, and this was babatka, right? Balls, bats, and gloves, and the other one was balls, bats, and gloves. If you switch the order of those, if you put gloves in the middle, all of a sudden your matrix multiplication could still be done, but you would get an answer that would make no sense. So you have to be careful in how you set things up. Now, PQRS, what did this stand for? This was their order, right? So if we thought these are the orders for the different stores, and this is the cost, when we think, what is my answer going to be? My answer is going to be a 4 by 1. And the 4 stood for the store's order, and the 1 stood for a cost. So we're going to get an answer, P, Q, R, and S, which will give us the total cost for each store. And so the outside numbers, if we have labels associated with them, what we get when we multiply, those labels get put there too, and we can get an understanding of what our answer means. So what we're going to do is we're going to put these into our calculator. We could do this by hand, but the idea of matrices is that if we can do these calculations quickly, it will save us time. So if you go to second matrix and go over to edit, what you can do is enter these in. Our first one was a 4 by 3. And we can enter those numbers in. So there's my matrix A. I'm going to edit matrix B. And matrix B is a 3 by 1. And then if you go to your regular screen where you do all of your mathematics normally, now you can go second matrix, select A, multiplied by second matrix, and then select matrix B. And it will do all that math for us. As well, we can say, well, maybe I need these numbers for later, so I can store what I just got as a matrix C. Second matrix C. And so now it'll automatically put all that data into matrix C for me, so I wouldn't have to retype it in. The store button is just above the on button. So we got 3110, 2505, 2810, and 2500. And we stored that as matrix C. So that might help us later because we might be asked to do other things for each of these stores, as in part D, matrix D, which includes a 2% shipping charge. So we could think about matrix D Now, if we wanted to add 2% to each order, we could take matrix C, which was the total order and the total cost, and what would we have to multiply it by? 1.02. So now we're multiplying by a scalar in front. We can go to our calculator, go 1.02 times by matrix C, and now we have the cost of all those. And if we need this for later, we can store it as matrix D. And now all that information is stored in our calculator. Of course, you could, again, do this all by hand, but the purpose of matrices is to make some of these calculations faster. And if you can make some calculations faster, then your business is more efficient, and then you make more money. Hopefully. So there's the shipping charge per item. So what is the amount owed by each store? Well, we just had that on our calculator from D here. I'll just drag that over. Uh-oh. We're glitching. I'll just write it down. PQRS 3172 3172.20 2555.10 2866.20 and 2550. And if we wanted to find the total amount of all of these together, what would you have to do? Just add them all up. Could you think of a matrix way to do that? Because we have this one right here. Yeah, I mean, it's so easy just to add those up. But this one here is, how big is it? It's a 4 by 1. If we want our total to be a total, it'll be a 1 by 1. So we would need to have in front of this one a 1 by 4 in order to make multiplication work. And if we had a 1 by 4, 1 row and 4 columns, and they were all 1s, right? It would multiply each of those by 1 and then add them up. But I think in this case, it might be just easier just to type them into our calculator and add them up. Did anybody try it and get a total? Around $10,000? $11,000? I'm thinking 11,000 something. Anybody got a number? Nice. Makes me think maybe I should stop teaching and start selling baseballs. If I could, if that's their daily sales, that'd be pretty good. I don't know who would buy that many bats on a daily basis, but you never know. Okay, so there's our first example.